Students, my name is Pragati Misra. In our last video, we were discussing about the symmetric group or permutation group S3, in which I told you that S3 forms a non-abelian group. Today, we will continue that topic. In order to understand the non-abelian property of S3, firstly, we have to discuss the product of permutations. So, we will learn today what is the product of permutations. I told you that S3 contains 6 elements. So the elements of S3 are identity 1, 2, 1, 3, 2, 3. This is the length of this is the cycle of 2 length, and this is the cycles of length 3. So firstly we will discuss what is the product of permutations. I will take 2 permutations and I will show you how to take the product of 2 permutations. So I am writing 2 permutations here. 1 is going to 1, 2 is going to 3, and 3 is going to 2. That is, I am taking 2, 3. If we see this, then 1 is going to 1. That is, we are getting a cycle of length 1, and there is no need to write this. And if we see this, then this is the cycle of length 2, in which 2 is going to 3 and 3 is going to 2. So this is the cycle of length 2. Now we will take another cycle to take the product of these 2 permutations, and that is 1 is going to 3, 3 is going to 1, and 2 is going to 2. In this case, we can see that this is also a cycle of length 2, in which 2 is going to 2. So this is the length of this is the cycle of length 1, and this is cycle of length 2, in which we are starting from 1. 1 is going to 3 and 3 is going to 1. So these are the 2 permutations, and now we will take the product of these 2 permutations. So the product of permutations is possible in 2 ways, but we will use only one way, and that is from right to left. That is, firstly we will see this one, and then we see this one. So if we see, then 1 is going to 3 and 3 is going to 2 in this permutations. So if we write the product of these 2, then 1 is going to 3, 3 is going to 2. So 1 is going to 2. 2 is going to 2 and 2 is going to 3. So 2 is going to 3. 3 is going to 1 and 1 is going to 1. So 3 is going to 1 actually. So this is the product of permutations. I hope you understand this. Now I will take one more example to show what is the product of permutations clearly. If we write these permutations in the cycle form, then this is nothing but 2, 3, a cycle of length 2. And if we write this, then this is cycle of length 2 again, which is 1, 3. And this is the product and this is the product which is the cycle of length 3. You can see 1 is going to 2, 2 is going to 3, and 3 is going to 1. We have started from 1 and reach at 1. So we are getting a cycle of length 3. If we take the reverse product, because we know abelian property is A operation B should be equal to B operation A, and if it is true for all elements of the group G, then we call that the group is holding the commutative property. So if we have taken 2, 2, 3, 1, 3, then if we take 1, 3, 2, 3, then that should be same as this cycle. Then we can say that S3 forms an abelian group. So we will check what is the result if we take 1, 3 first and 2, 3 at the second position. So I am going to write 1, 3, 2, 2, 3, 1. 1 is going to 1, 2 is going to 3, 3 is going to 2. So I have written the same permutations, but I have just changed the position of the permutations. So if we take the product from right to left, then what we get, 1 is going to 1 and 1 is going to 3 here. So 1, 3. 2 is going to 3 and 3 is going to 1 here. So 2 is going to 3, 3 is going to 1. So 2, 1. 3 is going to 2 and 2 is going to 2. This is 3. If we write these permutations in the cycle form, then we can see this is 1, 3, because 2 is going to 2, and here 1 is going to 1, so this is 2, 3. So this is the same permutation, but I have just changed the position of the permutation to check the commutative property. And if we see our right side, then this is 1 is going to 3, 3 is going to 2, and 2 is going to 1. That is 1, 3, 2. Again we are getting a cycle of length 3, but 1, 2, 3 is not equal to 1, 3, 2. So what we are getting is that 2, 3, 1, 3 is not equal to 1, 3, 2, 3. That is, the product of two permutations is not holding the commutative property. In this case, we can say that S3 does not form an abelian group. So S3 does not form an abelian group. So now we will discuss what is an even and odd permutation. A permutation which can be expressed as the product of even number of cycles of length 2, that is the transposition, is called an even permutation. For example, if we see 1, 2, 3, that is the cycle of length 3, this can be written as 1, 3. That is, you just take the first element and the last one, and then first and the second one. So 1, 3, this is the first cycle of length 2, and the second one is 1, 2. So this can be expressed as the product of even number of 2 cycles. So this is an even permutation. So this is even permutation. Even permutations, and this is even number of cycles of length 2. Now if we talk about odd permutation, so the definition is similar of even permutation, that is a permutation which cannot be expressed as the product of odd number of 2 cycles. In the case of even, we take the even number of transpositions, and in case of odd permutations we take the odd number of transpositions as the product of any given permutations. If it is possible, then that is called odd permutation. So I am taking one permutations, 1, 2, 3, 4. This is a cycle of length 4. I can write it as 1, 4, 1, 3, 1, 2. Now this is the length of this is the cycles of length 2, and this is 3 here, 1, 2, 3. So odd number of cycles are present. So this permutation is an odd permutation, because this can be expressed as the product of odd number of cycles of length 2. So I hope you understand this topic, and for such more videos please subscribe my channel. Thank you.